Hi, welcome to the December 14th. Well, it's the 15th, December 15th in most places, but where I live, it's the 14th meeting of the Kubernetes IoT Edge working group. Today on the agenda, we have an introduction to the Portainer project. This is a project for managing containerized workloads that potentially are at edge. The speaker is Neil Cresswell, who's the founder and CEO of Portainer. So I'll let you start, Neil. Thanks.
All right. We can keep this thing quite interactive if you so desire, so feel free to jump in and ask me questions as you go. As I said, I am technical enough to answer questions, so feel free. Let me just quickly start. I'm going to try not to bore you with slides, but I will walk you through some initial background information.
Okay, we can see that well.
Perfect. So Portainer is a company we've been around since 2017, and we're venture backed. Our primary investor is Bessemer Venture Partners, based out of New York. We are a open core company, so we have a free and open version, and we have a closed source proprietary variant of our free version. We're currently 58 people, 7 different countries, and that's 7 different time zones. So try and manage that. Just over 500,000 open source users around the world. And our uptake is pretty amazing. We're a total of 3.8 billion pulls of our product from Docker Hub. There's about 2,000 new deployments of Portainer every single day. It's simply insane how widespread we are. If you search for Portainer on YouTube, you'll be overwhelmed with the amount of content that's created. Our whole goal is to make container management simple. The mental burden that people are put under when organizations decide to embrace containers is quite high. And our whole goal is to reduce that operational burden, make it far easier for the mainstream to get running and use containers. That's our primary reason for being our primary motivating factor. I'll come back to more about Portainer later, but Edge. So the one big problem with Edge, and I need to start with this because Edge just means so many things to so many people. It's so confusing. If I say to you edge computing, what is it you think about? Is it Raspberry Pis? Is it IoT devices? Is it servers in a remote data center? It just means too much to too many people. So I always like to start with, first of all, what we mean in regards to terminology. So we always talk about the central DC or the cloud instance. We like to talk about the network edge or near edge. Network edge is like private base, private LTE, 5G base stations. Users or mobile devices access those things. They are out in the field. They might be an emergency responder. There's a base station in some management truck, and all of the responders have devices. You've got the device edge, edge gateway, far edge. Call it what you like. All 3 of those fundamentally mean the same thing. This is where it is a device or cluster of devices out there in a remote facility, industrial production facility, retail location, comms cabinet, a comms cabinet on the side of the road. There's all sorts of places for this. There is sporadic network connectivity, high latency, unreliable between the data center and the device edge. And that's the whole purpose of having this device edge. There are edge devices, tiny edge, again, call them what you like. These are an actual piece of physical hardware. Call it a robot, call it a computer inside a vehicle, call it a kiosk or a point of sale machine. Again, call it what you like. It is a machine out there that is running an operating system, probably running a container runtime, and almost always has either no access to the internet, public access to the internet, but will more than likely have a very high-speed connection to this device edge. And this is the whole point, is you have a device edge or an edge gateway in a site and hundreds or thousands of these edge devices calling into that device edge. So this is the terminology as far as whatever I use moving forward. I hope this is standardized, but it seems to change everywhere you look. So network edge almost always demands clustering. So because it's a really critical service, almost always it'll be multiple devices. It's a perfect use case for Kubernetes at the edge. It's really just a logical extension of the data center. You know, I've had examples of people where they're talking about floating data centers where there are cruise ships who have these edge devices, and it is literally a floating data center. It's not edge at all. It happens to be mobile, but these are monstrous racks of Xeon servers. You know, that's kind of edge, but a different variant of. Almost always it'll run persistent workloads, likely with transient data. You know, very rarely is there any kind of system or data or record held there. You know, that's not the point of edge. Edge is to basically store and forward, you know, store, process, forward. But almost always it needs to run some kind of persistence, and almost always it's a hefty size environment. Device edge also generally requires clustering, because the device edge's purpose is to receive these constant streams of data from devices out there, IoT devices. So if they go away, what happens to that stream of data? So almost always it's clustering. You know, the hardware footprint is often smaller, you know, i3s or, you know, the ARM64 type processors or even Core, but it's still sufficient enough to run something like Kubernetes unmodified, or at least a cut down version. So K3, K0, micro K8s. So, you know, there's these two, it's normally okay for Kubernetes at the edge. Often these things are self-contained. For the whole purpose being, the reason that these are there is because there is actually really sporadic internet connectivity. So that this device edge is there to aggregate, store forward, filter, process. That's why they're there. And almost always there's no inbound access to them. So they might be behind a NAT router. They might have some floating IP address from some provider. So it's very difficult to create any kind of persistent or static route from the core to the device edge. So, but the device edge can reach out normally pretty well. It's just like a free internet. Now, devices are something very special. Now, these are quite different, right? So these are nano devices. They're normally an ARM NXP semiconductor type processor, you know, Raspberry Pi. Not that you normally see that in production. I have, but you know, that kind of really lightweight machine. It could also be an Intel NUC. You know, it's far smaller. And it's almost always a custom OS that's provided by the board. So it could be a real-time operating system, could be a modified Linux kernel. It's something different. And in these situations, an orchestrator like Kubernetes is simply too much of an overhead. It just is. The devices probably can run Docker, but they have near zero chance of running something like Kubernetes, which is a real problem if an organization has actually standardized on Kubernetes everywhere. So if they're used to deploying applications in a Kubernetes construct, when you have hundreds or thousands or even millions of edge devices that can't run Kubernetes, you then have to now maintain two different mechanisms to maintain these things. These devices are internet connected. If you think about, you know, your CCTV surveillance cameras at home, you know, they're internet connected. They're also almost always on your LAN. So they have a very high speed local connection, and then they have an internet connection out to the cloud. They're always behind NAT. You can virtually never get into them. These things almost always require hardware pass-through, GPU, I2C bus, COM bus, you know, cameras. They almost always need this, and they're always, you know, stateless. You know, they're basically capturing data and streaming it to some gateway in near real time. So these are these three types of models. So how do we help? So we're this centralized service delivery platform. Now, this is a term that we kind of made up. It means manager of managers. It means a portal where from within you can actually control, manage, govern your entire container ecosystem. So it really helps you get started with containers, helps you get started and helps you accelerate the adoption of containers, no matter where it's deployed. So in the data center, in any one of these edge use cases. Now, service delivery platform is actually all of these things here. Now, if you're familiar with containers, and I'm sure you are, everybody knows to run these things in production, you have to have this platform. Like it or not, you have to have it. You can't put containers in production without observability. You just can't. So you end up deploying a Prometheus and Grafana type environment. You can't deploy this without some kind of identity and access management layer. You have to. So you end up, like it or not, building one of these platforms. Our whole construct is you can go and spend time building and maintaining a bunch of software, or you can deploy Portainer and get this entire platform out of the box in an afternoon, and then know that it's actually managed by us, maintained by us. So it's a turnkey solution to give you everything in these boxes within minutes, as opposed to spinning up environments. And we do this anywhere. So to go into production, regardless of the location, edge, data center, you have to have one of these platforms. Like it or not, that's just the sad reality. You have to do it. So you can either build one from a whole bunch of open source tools, or you can deploy Portainer. So, but whatever happens, you have to choose one. You can't put your head in the sand and say I'm gonna deploy. I'm gonna spin up a cluster, and I'm not gonna have any kind of identity and access management. I'm not gonna have any observability. You just can't. That's just not the reality of this type of platform. But why Portainer for Edge? So from day one, we've actually designed ourselves to run all three of the edge use cases. So not only are we awesome in the data center, but network edge, device edge, and edge devices, we're also very, very strong at. And we have a really high degree of customer interest. And I use the term customer to mean both open source users and our commercial users. We have a very high degree of interest with Portainer at the edge across all of those environments. We're completely runtime and orchestrator agnostic. So it doesn't matter whether you're running Docker, Docker Swarm, Kubernetes, and coming soon Nomad. They're all supported at the edge. Doesn't matter. As long as you have the ability to run a container, we can manage it centrally at the edge. We use our own exclusively written agent, which facilitates secure connections across the network, the internet, even through NAT. So Portainer doesn't need to talk to the agent as long as the agent can talk to Portainer. So we've got this connection, and it has a very high ability to survive unreliable, highly latent networks, which enables us to manage it in a very interactive way. We're both a container management tool, and we're also a device management tool. So, formally released in February is Intel AMT and Intel FDO, the FIDO, the zero touch device onboarding capability. So from within Portainer, you can list all of your edge devices. We can power them off, power them on, do a remote KVM, and we can deploy applications to them. So you can have an edge device in the middle of the outback in Australia, the middle of the rainforest. In Brazil, you can have these devices everywhere, and you don't actually have to physically visit them. You can completely control them from within Portainer, no matter where they are in the world. Now that's pretty magical, being able to say physical hardware. So take a brand new machine out of the box, install the operating system, install the container runtime, install an orchestrator, install the Portainer agent, bring it online without ever touching the device. That's pretty cool. And once it's online, if it goes offline, we can interact with the device out of band and remediate any issues, bring it back into service. We provide a really, really easy way to bulk deploy and update applications. So if you say, I want to deploy this application across all 10,000 of these edge devices, do it right now, we'll go and do it right now. It's as simple as that. So we've got this huge bulk activity management capability to just push out. And we let you group your edge devices together as well. And I'll go into more detail. So at the edge, we help the platform managers onboard their edge devices easy through our really simple agent. So you're not having to expose any APIs. You're not having to try and punch holes in firewalls. You simply deploy our agent on the device. The agent calls back to the Portainer instance, and you're managing it. It takes seconds. Lets the edge application owners deploy and manage and troubleshoot their apps, either one by one interactively or en masse. So you can say deploy them all, update them all, delete them all, and gives network and security teams the controls they need to say who's actually managing the devices, what can they do, when can they do it, and basically just get really good insight as to what's happening across their network of devices. So in regards to the edge features, so we have our edge agent. And this lets you onboard these edge environments, and these edge environments can be any one of the three that I said before. So the network edge, the device edge, or edge devices. We have our own agent. It uses 10 megabytes of RAM on the actual device. This device polls back to Portainer, and it's a frequency you can set there every 5 seconds, 10 seconds, 30 seconds, minutes, hours, a day. How often is it polling back? That's a very secure connection back to Portainer. And there's also a very, very easy process to replace that device. So if this device physically fails in the field, there is a button, deassociate. You can push that button. You can then bring a new device online, take over the identity of the one that's failed, and that new device will be completely updated with all of the applications, all of the configuration the previous one was running. So it's a very, very simple way to actually rip and replace a piece of physical hardware. And that was important for one of our customers, and we built that feature for a customer who was running edge devices in a very hostile environment and had a very high failure rate of hardware. And they said, we don't want to have to onboard a brand new edge device and go through the process to deploy all the applications. We simply want to take over the identity. This old one's dead. Here's a new one. This new one assumes the identity of the old one, and we're done. So we provided that capability. Edge grouping. Yeah, groups are important because groups let you perform the bulk actions. So we basically give you a couple of options to group. You can either statically assign them. So you say this endpoint, this endpoint, this endpoint, these here are in a group together, or you can say it's dynamic. And when it's dynamic, we use tags, which an admin assigns to an environment to describe that environment. So you could say there's a tag that says ARM64. You could have a tag that says site 1. You could have a tag that says CCTV. And then you can say automatically add devices into a group if it has the tag CCTV attached to it. And then you can use that group to deploy software associated with CCTV. You can say it has to have all of them. So you might have an application stack for CCTV for ARM and one for AMD 64. So you could say only deploy this application if it's CCTV and ARM, and AMD 64. So you can go and create a whole bunch of groups to dynamically assign tags. What's really nice is when you actually bring a new environment online and assign tags to it, it's automatically added to the group and it's caught up. So whatever applications have been deployed to that group, it's told you are new, you therefore you're out of date. Go and install all these applications. So it's completely automatic. And edge stacks, this is where we allow you to actually deploy your applications. So two options: you can either use an old-fashioned Docker Compose format, because Docker Compose is everywhere, like it or not, or a Kubernetes manifest format. So you can either paste in a manifest or a Compose file. You can upload one if you have a file. You can link to a Git repo. So if you have a Git repo holding all your Compose files, this is our simple GitOps tooling. You can link to the Git repo, and we'll poll that repo and keep it up to date whenever that changes, or you can use our templates. But whatever happens here, you simply provide Portainer with the application descriptor that you want to deploy, select the group that you want to deploy to, and hit go, and it will go and deploy it. And it can be one member of the group or 10,000 members of the group. It doesn't matter from our perspective. And as I said, whenever you onboard a new device into the pool and assign tags, the moment that it is added to a group, it is caught up. Also, any offline devices, if a device happens to be offline when the admin pushes an application, the next time the device is online, it'll realize I'm out of date and I need to go and deploy the missing applications. So it's this asynchronous message bus. There is tasks for you. You've got to do this. We have this other feature, Edge Jobs, and this basically lets you run tasks directly on the remote device. You can do anything you like. It runs as the root user. So you can do apt-get update, apt-get upgrade. You could do a reboot. You could do a shutdown now if you want. You could do Docker stop, Docker start, Docker scale. You can run any kind of commands you feel like. It is running on the host, outside of the runtime, physically on the host. You can run anything you like. And this is used a lot by customers to update the firmware. They've got on the host, they've got a binary, that the binary from the hardware manufacturer that they can use to flash the firmware. So you can basically use this for anything, and you just schedule it. You can run it right now, run it in the future. You can run it every day at this time. So it's just a nice way to physically run things on the remote device. So the Portainer platform sits in between your users and the environments. So all of your users, both admins and end users, interact with Portainer. Portainer then interacts and manages the backend clusters. So we sit in the middle. We act as a Docker and Kubernetes API proxy. So if you don't happen to like our web front end, that doesn't matter. You can generate from within Portainer your kubeconfig file, and you can pass that kubeconfig file to your user, and they can go use Lens or go use Headlamp or Octant, and they will use that to talk to Portainer, and Portainer will talk to the backend with any of the access controls that have been assigned by the admin within Portainer. So we're a true Docker and Kube API proxy through the backend. We are the centralized identity and access management inside the underlying environments, Kubernetes. You don't have to install any kind of identity provider. You don't have to configure any RBAC or any user accounts. Portainer manages all of that for you. So Portainer authenticates your users on your behalf, and we create shadow users in the underlying platform. Your users themselves never have a direct login to the underlying platform. They simply can't. So Portainer is self-hosted. As I said, it's an open source project and a closed source variant. It's self-hosted. It runs somewhere inside your firewall. One instance of Portainer can run up to 20,000 environments, so 20,000 remote edge environments. We're currently in the process of scaling that up to 500,000, but right now 20,000. You can import any environment into Portainer. You know, we're not helping you build clusters. We help you manage clusters. So as long as you have a running container environment, you can deploy our agent. You can run that or manage it by Portainer. You connect Portainer to your auth provider, LDAP, OAuth, so Azure AD, Google, Discord, GitHub, anything you like. As long as it's an OAuth provider, we can connect to it, and that acts as the centralized identity and access management. So the authentication, as I said, users log into the Portainer server. The Portainer server then connects them to, securely to the back end. The users have no access to the back end directly. All of their access rights are determined by the role and privilege they are assigned within Portainer. So you don't have to muck about creating role bindings or cluster role bindings in Kubernetes. Portainer does all of that for you. You simply assign in a human-friendly way the role to the user, and we propagate that through to the back end. And the agent, we run this lightweight agent. As I said, it's roughly 10 megabytes of memory. It's just a little Golang application that runs inside the environment. On Kubernetes, there's just a singular copy of it runs somewhere, and if it fails, it simply restarts elsewhere. On Docker Swarm, it runs on every node in the cluster. Docker Standalone, it just runs in the runtime. And there are two modes of operating. There is our standard mode, where Portainer expects to be able to connect to the agent over a routed network, so a LAN. And then there is the edge agent, which is where Portainer expects not to be able to connect to the agent, but the agent connects to Portainer. And in that case, the agent polls Portainer, it checks in, hi, I'm here, hi, I'm here, hi, I'm here. So depending on your network construct, you can use either of the two agent operating modes. If you have a private WAN, you can probably just use our regular agent. If you're doing this over insecure public networks, you absolutely will be using our edge agent. If your environments have random IP addresses, no fixed IPs, you'll be using our edge agent, as long as Portainer is static. So the edge agent, it's important to understand this because, obviously this is a connection from your remote environment into Portainer. So communications are always initiated from the edge agent back to Portainer. And it's along the lines of, hi, I'm agent, and each agent is assigned a UUID. hi, I'm agent UUID. My hashed passcode is whatever it is. Is there anything that I need to do? And the agent just checks in on this regular basis, is there anything for me? Portainer responds back to the agent, nope, for now you're all good, and it waits and goes back in a loop cycle and does it again. Or Portainer says, yes, I need you for an interactive management session. Please open a reverse tunnel. The agent will then establish a reverse tunnel back to Portainer, and then the admin can go and perform interactive management tasks against that agent across the public internet. Or Portainer will say to the agent, you don't need a tunnel, but there is a batch activity waiting for you. Please run this task. The agent then runs the task and then reports back to Portainer, I've run that task, and no tunnel is needed to be opened at that point. So that's an asynchronous, almost MQTT. It's not, but almost like MQTT, just the publishing of a message. The agent picks up the message, executes the message, and responds back, I'm done. So the edge devices don't need any fixed IP. They don't need to be exposed to the internet at all. The agent needs to reach Portainer though. When the agent's needed, it posts the message through based on the polar frequency. It has the tunnel. The tunnel is based on, it's an SSH tunnel over a WebSocket connection over HTTP. We use a pre-shared key to sign communications, which is created when the agent is first defined. Neither party ever shares that pre-shared key over the network. They both know it, and they basically sign a temporary password to open the tunnel each time. So when the agent checks in, it's using a hash, using that pre-shared key. The Portainer knows how to decode it and basically use this for its passcode to get in. So it's a short-lived session. The tunnel is only open for a few minutes for whatever actions, and then the tunnel's pulled down again. So it's not long running. And the agent, as I said, can perform bulk actions without actually opening the tunnel. So what I'll do is rather than just keep talking at you, I will show you what I mean with the actual product. Oops, I shared that screen rather than I meant to share this one. So this is an instance of Portainer that is running out there on the internet. In fact, you could go and log into this right now yourself. Here from this instance, we have a kube cluster. This happens to be inside the cloud environment. This is running in. We have a Docker Swarm environment. We have 3 edge devices. Now these could equally be edge clusters. It doesn't really matter. They're singular nodes. And we just have a rootless Docker host just for fun. So we've got these 3 nodes. We've got an edge Swarm cluster, we have an edge standalone Docker host, and we have an edge Kubernetes cluster. So these are the 3 environments we have here. Now I have already onboarded these environments, but it's relatively simple to come into Portainer. You go into environments, you add an environment, and it's our edge. You give it some details, you give it the URL that the agent calls home to. It gives you the instructions, and you deploy this in your cluster, and it takes mere seconds. I'll just quickly show you what happens when we raise the flag to say that the tunnel is needed. So if I click on this edge swarm as an example, this is basically now saying, or raising a flag that says, agent, I need you. The next time the agent polls home, it says, yes, I'm needed. The agent will then open that tunnel. Once the tunnel is open, have I broken this before? I was just playing around before reloading things. Once the tunnel is open, you can then perform interactive management sessions against that endpoint. This is why you don't actually update environments just before. Here we go. So this is now, I'm now connected to this edge swarm cluster over the internet. I have no inbound access to that at all, but I can now interactively manage this device as if I was. So I can do pretty much anything I like to it because I've got this reverse tunnel. The moment that I navigate away, it'll start a countdown timer and then eventually close the tunnel, and it's done. So a few minutes later. So that takes a few minutes while it waits for the agent to check in and say, yep, I need you. It opens the tunnel and connects. Now, outside of that, we have in the sidebar here these edge features. Now, these are not enabled by default. You have to come in and turn them on through our edge compute features. But once you have them on here, you can see them here. And you have these edge groups, edge stacks, edge jobs. So edge groups, you come in here, add an edge group, and you can see here are my 3 edge nodes. And I could just say all edge if I want to, and I can go and add all 3 of these to the group. create a group, and I've created a group with all three in them. Or I can actually say, well, I actually want to create a tag, and I can call it anything I want. So I could say, West, create a tag. I can then go to the environment, let's say Kubernetes, and I could assign a tag to it, update it. And once I've updated the tag, I can then start going and creating groups. And with those groups now, I can start to apply filters. So I can say, I want to create an Edge group, dynamic. And as long as the endpoint or the device has the tag West associated to it, add it to this group.
Can an Edge node be in multiple groups simultaneously, or the intent
Yep,
is
absolutely.
that it's okay? Got it.
No, it can be multiple. Like this is actually already in the static group as well. And we're actually smart enough. If you're trying to deploy an application across multiple groups, and there is an environment that's in multiple groups, we won't deploy the application multiple times. We'll say it's actually already deployed because of membership in another group. Don't redeploy it. And again, if I had multiple tags here, so you see here right now, Edge Kubernetes is actually in this group. If I say GPU, so it has to have the tags West and GPU, there's now no endpoints that match. If I change it to partial, now it'll say, or add an endpoint to this group if it has either West or GPU tags. So you can start to get a bit smart. Once you define this group, it's automatic from that point on. You're not adding endpoints to groups, or you basically just, when you bring online a new environment and you add a tag, they'll automatically be added to the group dynamically. You don't have to do anything special.
Okay, let me restate what I think I got out of this then, and you can correct me if I'm wrong, but the groups are basically a mechanism to do policy-based management at scale, so you don't have to atomically manage these things a node at a time. The tags give you a mechanism to use logic clauses to identify what goes in a particular group or not. And Edge nodes can be in multiple groups, so some of the nodes could run two different classes of apps or services, others just one, based on what tags you'd apply, which would cause them to go into different groups. Is that about it?
That's correct. Yep.
Okay, thanks. Got it.
So for example, here I've got a group that's Docker hosts. I've got a group that's Kube hosts, and I've got a group that's all. So basically in all, they're all three of them. And I've created these groups here, one of which is dynamic. So if I onboarded another Kubernetes cluster or another cluster and tagged it with the tag West, it would be added to this group automatically. But once you have the groups defined, you can come into Edge Stacks, and Edge Stacks is the way to deploy applications. Now, if I want to start with a Docker one, I can just take this Docker compose file, and I can say, I want this to be against the Docker Edge group. So the Docker Edge group is going to run or have this application deployed, go. So you'll see it'll refresh, it'll go blue in a minute to say that an endpoint has acknowledged. So an endpoint has been told there is something pending for you, but it's not doing anything. It'll then process it. It goes green once the environment has actually deployed it. So green means that the remote Edge environment has already deployed it for me. And I can click on this if I want to. I can go to the environments and I can see Edge standalone node, its status okay, it's running. I can do the same thing and say Edge stack, and I could say Nginx test. I can do the Kube Edge, and I happen to have a Kubernetes manifest here. Kubernetes, paste in a manifest, go deploy, and same thing. It'll basically go and wait. So the endpoints are seeing who needs it. Here you go. One endpoint has acknowledged it, and in a few seconds later, there you go. So this one has been picked up and acknowledged and deployed by Edge Kubernetes. So, and that could be one, it could be 1,000.
So let me ask you this: is an application have a cardinality with container images of 1-to-1, or are they more like pods? In other words, can an application be composed of multiple container images, or is it always exactly one?
An application is a manifest or a compose file. And so in this case here, that this is actually this is two replicas of Nginx on this one here, the Nginx test one. There's two replicas, so that's actually going to be two pods. So,
Okay.
but I could actually easily say have another service here and have another service, have another service. So it's basically an application stack. So it can be a singular pod, a singular container, multiple pods, anything you like. It's simply a manifest. So as long as it's a Kubernetes manifest, we can deploy it.
Okay.
Have you thought? Sorry, go ahead, Steve.
And then to get the application there, are you counting on the underlying Docker runtime to do a standard Docker pull out of an image registry?
Absolutely.
Or does Portainer move these binaries around and monitor it by itself?
No, so we are simply telling the remote environment, go and run this. So we're telling Kubernetes basically go and run this manifest. We're telling Docker go and run this run command or this compose file. So in which case it does a Docker pull or whatever it needs to be. We are, by the way, going to be adding a feature where we will let you warm up or pre-stage images. One of the real big issues, Docker was not really designed for the edge, and neither is Containerd. When you do a Docker pull, if you have an unreliable network and your network is disconnected, the pull will fail. The pull doesn't resume; it restarts. So you may be trying to pull a 200 meg image over a satellite connection or unreliable radio link, and it keeps failing, and you could end up pulling gigabytes of data until you finally get the image. And we actually have a user who has instances running on ships, and ships sail through bad coverage areas, and things like the pulls are failing. And so
you often want them staged
them
so that if you do a power cycle recovery too, and the internet is no longer there when you come back, that you have some form of caching it locally.
Yeah,
anyway,
so
you answered my question. So Kate, back to you. Sorry I interrupted.
No, I cut in. I was just wondering, when you push that deployment in that Kubernetes scenario, so that deployment YAML to the agent of that Kubernetes cluster, is that agent effectively deploying that or sending that to the Kubernetes API server, or are you somehow directly interacting with the API server?
No, we're not. So basically, all comms is between Portainer and the agent. So we're talking our own API between us and the agent, and then the agent talks to the API server. We are strong believers of not exposing your API outside of the cluster, even though everyone does it. We believe don't do it. So for us, the API server is only available on localhost in the cluster, and so the agent runs in the cluster. It can connect to the cluster's local IP address and connect to the API server that way. So our agent sends the instructions to the API server locally within the cluster.
And the agent's running as a localized component. It's not containerized, right?
It is. No, the agent is a container. The agent itself is a container.
So for its RBAC policies, what do you define? What Kubernetes resources do you define as a manifest? Is it can create jobs, deployments? Is it anything, or is there only a subset of resources and is that configurable?
The agent runs as cluster admin. It is configurable, but everyone just runs it as cluster admin. But yes, it is configurable. It needs to be able to read namespaces if you want to create namespaces. If you change permissions, we have a lot of unhandled errors in that regard. We expect the agent to have cluster admin.
That makes sense.
Yeah.
Just one other question. I was wondering, would you all consider also having Helm be an option? So maybe pushing what would look like as a Helm installation, and then the agent somehow act upon that?
Absolutely. We just actually added Helm into Portainer. In fact, if I click Helm, you'll see it's still a first version. And absolutely, we basically got the Helm support in Portainer. It's very, very easy to use. You can edit the values directly. And yes, we will absolutely be bringing that to Edge stacks. And again, we're adding Nomad support so that we'll actually have the ability to do Nomad deployments as well. So when you hear there'll be another option, Nomad, then you can paste in Nomad runtimes as well.
Super cool.
Nomad's having a bit of a resurgence, believe it or not. Okay, so these are here running, and if I happened to go and click on the Edge Kubernetes environment now, that just for fun, I've got the Edge, this Edge environment. This is micro K8s running on DigitalOcean, running in Bangalore, to try and get as Edge centric as I possibly can, and firewall rules so there is no inbound access to it. And so if I come to applications now, you'll see, fingers crossed, the Nginx deployment and 2 replicas as we pushed out. So that was done manually. And again, because of the reverse tunnel, I'm able to connect to it if I so desire and do interactive management. The other cool thing is I can actually do a kubectl shell from within Portainer to that Edge environment across the internet, across that tunnel, and without having to worry about kubectl on my local machine. So it's a pretty useful thing. And here you see the kube config file, because we are this kube proxy. So this is the kube config file with Portainer as the authentication engine. Kubectl get nodes. So there's the micro K8s instance there. So it's very handy way. Now, again, the interactive thing, not everyone needs it. A lot of people just want to be using this whole asynchronous model, but if something goes wrong, it is quite nice to know you can click on it and get an interactive management session. And this, while this one's active, the tunnel will be held open. So Portainer won't let the tunnel close. We'll keep that there's a keep alive, and the tunnel will stay open until I navigate away. Then the tunnel will basically close down. So next time I go back, it'll open the tunnel again. So we've got these 2 running here. If I delete them from here, as you would expect, they delete on the endpoint. So it's completely managed from within Portainer. You can also come in here and say, I want to change it from this 8 to something else, change a port, click update, and this will go back to 00. They'll acknowledge it, and then they will redeploy, assuming there's not a port conflict. It'll redeploy with that revised port, and you're fine. So there you go. And so now that's now using port 8990 as opposed to 8989. So you're basically controlling every element about the Edge deployment from the centralized location. And again, we tested this in partnership with Intel, and we tested it to 15,000 devices quite comfortably. 15 to 20,000, it was okay. We started to self-DDoS ourselves though. The Linux TCP stack thought it was being DDoSed. So 20,000 was our current maximum. And then, as I said before, Edge jobs lets you run anything. So if you want to do a DF on a node, you can actually just go and run it, choose which one you run it on, or stand on this node here and go and it'll go run a command on the node for you at the time you specify. So pretty nice way to do anything. And again, you could do shut down -H now if you so desired, and it would go and shut down that node. And that's not ideal, but you could do that. So this is a very useful tool to go and perform physical device management or anything else you need to do.
So in terms of this physical device management and provisioning, you'll take it just from factory unimprinted all the way up to installing the OS and then the container runtime and doing it from there? Or have I put words in your mouth? But that's what I think I heard.
No, so there's going to be a new setting under settings, which is enable Intel AMT. So you just flick a switch, enable Intel AMT. If you come into our templates, you'll be able to deploy the Intel AMT stack. Once the stack is configured and you've enabled the AMT option in here, you'll be able to go into an environment here and associate with the AMT environment. Once it's associated, you can do remote KVM. So remote KVM, power on, power off, using the vPro capabilities. In the future, we're looking to add support for Redfish as well. So any server baseboard management controller. And for the Intel FDO, we are having a new item here called Edge Devices. And Edge Devices lets you import the vendor voucher. So when you buy a physical device, the vendor will give you an ownership voucher. It's a digital certificate, which is a voucher proof of ownership. You import that voucher into Portainer. The device, when it is plugged into the network and turned on, it beacons home to the FDO call home server and says, "Hi, I am this device. Here is my voucher ID. Who owns me?" If it's been owned, in which case, the Portainer admin has owned it, the Intel public service says you're owned by this Portainer instance. It then calls back to us and says, I'm a brand new device. What do you want me to do? And we then give it instructions. So we want you to basically reboot, partition your drive, install Ubuntu, install Docker, install Kubernetes, deploy the Portainer agent, and call home. And the device will then go and run all those instructions hands-free. So all you need is a courier to ship a device on site, take it out of the box, plug it in, turn it on, and from that point on, it's hands-free. So it can be a courier, it can be a staff member at a remote location. They do not need any IT competence at all, other than plug the purple cable into the purple hole. As long as they can do that, then everything else is hands-free.
And then you inherit, I'm not an expert on this Intel technology, but I believe that it does hardware device identification and potentially has something like a TPM for storing things as well. Is that true?
That's correct.
And in terms of doing this at scale, is there a similar mechanism you have where you can tag things and put them in groups rather than do this level of device management one at a time?
Absolutely, yep. So same thing with FDO. You can create the FDO deployment groups, and you can say all of these ownership vouchers are owned by site X. Put them all into the site X group, and then say, site X, I need you to go and run the script, and they'll go, and all the devices inside X will go and run that script and come online. So yeah, it's the initial provisioning tool though. Once it's provisioned, it's done. You can put it through a refactory process using AMT, go into the BIOS and tell it it's now new again, and it will go through the process again. But once it's provisioned, FDO is hands off.
So what if I have a scenario where there's a CVE on my Linux distribution and I need to do an update to the OS? You're saying I need to act as if it was a from scratch install rather than attempting to do an update of just the OS?
In that case, you could use Edge jobs, and you could just use the apt-get update. Yes, FDO is an initial provisioning tool. So it's a device onboarding tool. Once it's onboarded, FDO lets go. You can format it and start again, but it's an initial provisioning tool, and that's why the combination of that and our Edge jobs to let you do apt-get upgrade will actually give you the best of both worlds there.
What about a scenario where you wanted to do something like a firmware update to a device? Does that fit into this stack anywhere? Or
interestingly enough, that's one of the next pieces of work we're doing with Intel. We've actually got a partnership with Intel, a co-development partnership. That's one of the next things we're looking to bring is a project they have which lets you do remote firmware updates. And so we will likely provide that capability. Right now, you have to use the FW update binary on Linux or Windows, and you execute that from Edge jobs, which is okay, but a bit rough. The other product is far more granular. It's out of band. It does the boot block recovery. If something goes wrong, it waits till it flashes the new, then swings across the boot block. It's a far more handled mechanism. So that's coming as well.
Okay, thanks.
And so they're basically the Edge features. We are adding additional capability for Edge devices that are in industrial constructs. A lot of our Edge customers now are using us in industrial settings, and this environment, adding this Edge environment, we are mutually validating that Portainer trusts the agent and the agent trusts Portainer. What we're not doing is validating the physical device. So we're actually further supplementing this Edge agent authentication with a mutual TLS handshake, where we're able to, where the customer has a Amazon or Azure managed IoT stack, they can issue a device cert, a client cert, and store it in the TPM module. The TPM module will then expose that cert to the agent. When the agent connects to Portainer, it'll connect and say, I am agent X and I am device Y. Here is my cert. And so and when that happens, we will basically go and validate that cert, and we'll have a function very soon to say, do not allow agents to connect unless they are also a trusted device. And that'll be out in the March timeline, which we have again created because customers have asked us for it. So that will basically validate that the agent is trusted, Portainer is trusted, and the physical device is a known corporate owned asset, as opposed to something that someone spun up and installed an agent on themselves. So industrial has very high levels of security. So they wanted this extra level of protection. So I hope that makes sense. And
At
that
the
was,
beginning, oh, sorry.
no, go.
At the beginning, you mentioned how these 3 tiers of devices, and at any point when you were looking at the portal, were you discussing those tiny edge devices? So what do those scenarios look like? You were mentioning that's like a 20 megabyte agent. Are you able to put that on something like a smart camera, or is it more like the intermediate layer? I can't remember what device edge is what's communicating with those devices. How does that interaction work?
Okay, so our agent is so lightweight. So the only difference in my view between an edge device and a gateway is that the edge device doesn't run Kubernetes, in all honesty. The edge device runs Docker. And so from our perspective, as you saw, it doesn't make any difference to us whether the edge device is running Docker, Kubernetes, or Docker Swarm. We can deploy and manage applications to it. And so that works very well for us. We have a lot of examples of our customers who are running very, very, very lightweight NXP semiconductor CPUs or single board computers running Docker. 256 megabytes of RAM, megabytes, not gigabytes, megabytes of RAM. It's physically impossible to start even the most lightweight of Kubernetes distros on those. Yet they can run Docker perfectly fine and run their applications. And so in that regard, from Portainer, it makes no difference to us whether it's Kubernetes or Docker standalone.
This is maybe brainstorming of distant futures, but what about things that are so resource challenged they can't even run Docker?
That's why we're so interested in partnering with Nomad, because Nomad lets you run a system D. So Nomad as a scheduler is also very lightweight and lets you run system D. So that's why we're kind of interested in that one.
And what about maybe no Linux either and WebAssembly? Have you looked at that?
We have not. That is I'm ashamed to say, beyond my level of mental comprehension. I would need my engineering team to figure that one out. But at this stage, no, we have not. But technically, there's absolutely no reason. All we care about is it's an application. So the agent is acting on behalf and doing things.
I believe Nomad can orchestrate WebAssembly.
There we go.
So that may come with your Nomad integration, that next step.
Yep.
So you mentioned the open core. What features of what we saw today are upstream, and what are the?
All of them are upstream.
Okay, cool.
Yeah, 80% of
So
our
what was
features,
the part of the enterprise offering?
let me show you. Hang on. So in the enterprise offering, we have authentication logs.
Mm-hmm.
So you can see the excessive failure. You can see the activity logs. So who's done what. You can configure multiple rules. So when you are assigning access to an environment, this Kubernetes environment as an example, we have multiple roles that you can assign. Now these, rather than manually creating RBAC rules, each of these map to a bunch of underlying RBAC claims. So when you assign these roles, you have this in the free version. Let me just show you. In the free version, if I try to assign access, and you can see here, these roles are grayed out. You can only use a standard user role. So we've got one role in the free version. These other roles here are grayed out. So there's this kind of stuff. If you go to the authentication logs, it doesn't work in the free version. So the main difference between the free version and the paid version is compliance, security enforcement, policy enforcement. It really, it's designed for businesses who are using it across multiple teams, across multiple environments. So we said, if you are a person, a home user, a home lab, a single developer, a team, use the free version. If you are multiple teams enterprise-wide, use the paid version, because your CISO will demand it.
Sounds good. Thanks.
Cool. And that's all I have.
Well, that was a great presentation. Thank you. And we're
Right on time.
1
Yeah.
minute to go, but I don't mind leaving the Zoom open for longer if people care to, and if you're willing to stick around a few minutes extra.
No problem. I'm just Neil at Portainer.io, so you can email me, and I'm very receptive.
And then if you don't mind, if you can shoot me a link to the deck later, I'll put it in the group's agenda notes document, and maybe drop it in our Slack channel too.
Mhm.
The recording should be posted in a few days, but sometimes I know people like to go back and look at the deck itself, and especially if some of the things you showed were links and things.
Yeah, no problem. Okay, and we have a lot of customer footprint in Germany, FYI. Being obviously the center of industry over there, we have huge uptake of our Edge solution in Germany. Automobile and electric supply and all sorts of things. Amazes me. All good. Thank you for your time.
Okay, well, thank you. And you're welcome to continue coming to the group to listen. I don't think we have anything known for January yet, but sometimes they're like this, sometimes they're just informal chats, but I think I learned a lot, and thanks again for presenting.
No problem.
That's one
Thanks,
thing
Neil.
maybe I wanted to mention, Kate. So you saw that we played a little bit with WebAssembly and Crosslet and all that kind of stuff for our last session. What interested me is maybe how we can find more way to be involved into all WASM on Edge kind of thing, like connect more people, see where to track things, where the gaps, where we can ask for help, what we can do ourselves and things like that. So it's nothing urgent, maybe something to discuss on one of the meetings in January.
Yeah, no, I think putting WebAssembly kind of on the schedule there. I think one community for that would be the Bytecode Alliance.
Okay.
I feel like a lot of the work's happening there. And I don't know if they have a Slack, but we could certainly reach out and ask if some of those folks want to come together. I think one of the interesting parts about WASM, or specifically the WebAssembly systems interface, to me, that definition of what it means to run WebAssembly on the server. I think what's interesting there for me is those decisions that are happening now that are going to shape the future of what you can do on the server with WebAssembly. So it'd be interesting to have some people who are directly involved in that and designing those specs to come and talk about those pros and cons and kind of those points that are hard for them to decide on, such as sockets and what are the decisions there. I'm very curious about it all. It's nice being a part of it somewhat with Cresslet, but there's endless opportunities to learn there.
Yeah. Neil, I just want to make sure you are following, and stop me if I'm overly explaining this, but if you're new to WebAssembly, this was sort of a hot thing at KubeCon. They even had the WebAssembly Day, which I recommend looking at the videos, but the concept is that it's an alternate form of container packaging. In fact, one of the founders of Docker made the comment that if WebAssembly had been there circa 2011 when Docker was invented, maybe they wouldn't have needed to do it. It has some aspects that are arguably superior to Docker, meaning that it isn't tied to one OS or even one CPU. It executes bytecodes. There are some aspects that could be a plus or a minus depending on your goal. It has a what I describe as a tighter sandbox. So it limits more severely access to the network and the file system. But that could be a good thing in some ways to ensure security. And bottom line, it's potentially more portable, smaller in terms of the binary, which could be a big deal at edge. And it has a much shorter startup latency based on people's experiments. So a Docker container from time to get the binary there to when it actually executes its first line of code is probably tens to hundreds of milliseconds. If you put it under an orchestrator, it might even be longer than that, but a WebAssembly could get there in single digit milliseconds based on some of the reports people gave at that WebAssembly day. And once again, that might be a real good match to edge applications. Maybe it's a good match to trying to do the equivalent of function as a service out at edge too, for, you know, alleviating the 0 to 1 instance latency startup. But combining that with something to manage it, you know, it seems like many people are considering that WebAssembly at scale is going to need an orchestrator. Can you morph Kubernetes in such a way to allow it to be the orchestrator, or is some new thing going to emerge? This Crustlet project they were talking about is an effort to get something like a kubelet to manage WebAssembly. So just throwing that out there to give you some context in case you weren't up to speed on that.
Yeah, I was at the Linux Foundation event in Napa, and I went to a couple of sessions on WebAssembly at the edge, and I thought at the time that's pretty cool. I've got to get across that. So that's on my to-do list for early next year, is understand what this is and the opportunities. Absolutely.
But yeah, maybe if Portainer can manage a Kubernetes cluster and you could put Crustlet in that cluster, that might be another way to have it manage WebAssembly.
Absolutely.
Maybe not the best way, but maybe it is the best way. I don't know.
Yep. Yeah, you could probably have a kube control plane running in a edge aggregator, and then, you know, the Crustlet's running out on edge devices, which could be another way of doing it as well. So that way you've not got the overhead on the physical device. So that could be an interesting way to see it. So yeah, it'll be good to get some time next year to play with that.
Yeah, the other thing for management that has come up in this group, and I think Kate is very familiar with it, is this device twin concept, where you've got some devices there that are very resource challenged, or maybe they're just dedicated single purpose devices that really aren't intended to run generic apps, but you still would like to manage them. And, you know, there might be an opportunity there for Portainer to, in a future release, to extend off into that territory too. It probably isn't worth inventing device twin code at this point, because there are open source projects that do that, but there might be an integration opportunity to put some of these things together.
Yeah, our whole ethos is to be this manager of managers, and to provide this seamless integration. You know, we want to make it so easy to use the technology in Portainer. That's our UVP. Our UVP is not building a better Prometheus or build a better something else. Our UVP is make it so easy to use. So any kind of technology that's now accepted mainstream, if it's hard to use, that's where we excel. We find a way to make hard easy.
Cool.
Yeah, I think the going along with what Steve was just saying, I think the question is how do you manage devices that you can't get the agent on? And I think that's an interesting question. And maybe that goes along with just the fact that we have so many brownfield devices, or just really constrained tiny sensors. And I think in your original diagram, you had them more as peripherals to those ones that do have the agent.
Correct.
And I think that's a completely reasonable way to do it, especially if you're plugging in other things that do that digital twin approach or connect them up in a different way. But yeah, that's certainly where I spend my time thinking about
Yeah, we're not trying to be a replacement for the likes of Greengrass, which is designed to manage the actual device. Like I have a CCTV over my shoulder here, and I can't manage that, but I can manage the device that thing is actually talking to. But we've actually started experimenting with running our agent as an actual daemon, not as a container. And then once it's a daemon, we can kind of do anything we like at that point. And it works in theory. It's still early days. We're only Series A funded, so our ability to do much R&D is still somewhat limited. So hopefully next year that changes.
I mean, it was a really impressive presentation all around. I think it's going to be really exciting to see all the different scenarios y'all enable.
Yeah, cool. Thank you.
Okay, well, thanks for staying over, Neil. I'll
problem.
second that. It was a great presentation and appreciate it. And hopefully we'll talk again next year.
All right. Thanks for the opportunity.
Okay, bye,
See you all.
everybody.
Bye.
Bye, everyone.
Bye.